Stopped here. So what do I have to do next? Don't tell me how to do it because we kind of got stuck there, right? But tell me, what do I have to do next? I'm looking for the process and not necessarily the steps on how to do it. What do I need to do next in my steps to solve the question? What's needed next? What do I need? This is where we stopped yesterday. I'm not looking for an answer, so don't have to tell me an answer. I just need to know, what am I attempting to do? What's the next step that I need to answer the question? Hmm? Mhm. Exactly. Yeah, I need to find the zeros, right? I need to find the x values that will make this equal to 0. Okay? This is a statement. It says 0 equals negative sine squared of x plus cosine squared of x. Okay? So in other words, it says this: negative sine of x squared plus cosine of x squared. Okay? That's what it says. So it's not like something I can subtract x from both sides. It's not something I can factor. It's not something I can do anything like that, right? So how do I do it? Well, you kind of have to do it more. You just have to kind of understand what equations or what trig functions mean. Okay, so what I'm going to do here is, I see I have a negative. What can I do to make that positive? But if I divide by -1, then I also have to do this guy, right? And then that makes this guy negative. So how can I make both of them positive? Because I'd rather deal with positive sine than negative cosine. If I do that, that would give me 2 negatives. Even easier than that. So instead of doing 2 steps, how can I just do it using 1 step? What's 1 step I could do to make everything positive? Mhm. That's what I was thinking. Yeah, add sine of x to both sides. If I add it to both sides, now I have a statement, another statement. Okay, now it has this statement. What does that statement say? Sine squared of x equals cosine squared of x. What does that mean? Mhm. They need to be the same, right? So the squared, how do I get rid of the squared? If the squared's bugging you, how can I get rid of the squared? Mathematically, how can I get rid of the squared? As long as I do it to both sides, right? It's okay. So if I square root both sides, what do I have on the left? Just regular sine of x. Okay, so now we're starting to cook. That's where I'm looking for. Where are those two guys equal? Where are those two guys equal? And I'll tell you what, my face doesn't have the answer. What does have the answer? Some of you guys are doing it. The pink sheets. The pink sheets have the answer. Yeah, unless you have this memorized, look at your pink sheets. Tell me where these guys are equal. Where are these guys going to be equal? That's what I need. Okay? So make a list of, it's going to be a couple different spots. Where are these guys equal? So if you look at the bottom half of the pink sheet, it actually tells you what sine is at every angle and what cosine is at every angle, right? So where are sine and cosine equal? Yeah, always radians, never degrees. Pi over 4 and 5 pi over 4. Okay. All right. Now, let's go back. Let's zoom out a little bit. Those are our zeros. Here's the problem. That's our interval. We don't care about anything that's outside of the intervals, either bigger or smaller than that interval. Okay, so this is our interval here. So which of those values it doesn't fit the interval? Which one? 5 pi over 4, right? This guy doesn't fit the interval. Here's the thing though. That guy's not the only one. This is definitely a 0. But there's also another one. Your sheet doesn't have it. Why doesn't your sheet have that answer? Because it has also negative, right? Negative. So let's look at this. Let's look at this guy. Again, something that has nothing to do with calculus, but it's important because we need it to solve the question. Okay, so here is the unit circle, right? So you guys told me pi over 4 and 5 pi over 4. I think that's where 5 pi over 4 is. Let's see. Yep. Okay. But here's the problem. The interval goes from pi over 2, so let me use a different color, to negative pi over 2. Well, where's negative pi over 2? Mm-hmm. Bottom where? Right here? It's the same as 270 degrees, right? It's the same location. So what they want to know is here. Where on here are sine and cosine the same? Okay. So again, so we have pi over 3, or sorry, pi over 6, pi over 3, pi over 2. Negative pi over 6, negative pi over 4, negative pi over 3, negative pi over 2, right? That's the hemisphere I'm looking at, okay? So how can I use my chart? My chart doesn't have any negatives. My chart does not have any negatives. How can I use my chart to find this stuff down here? Because if I look on my chart, this is what you guys are going to do. This is what students do. Mr. Flores, mine doesn't have any negatives. How do I use it? But you can use it. How can I use my chart with negatives? How can I use my chart, the purple pink chart that you guys have? How can I use it for negatives? Because you're going to have negatives. There's no negatives on here. None of these guys here are negatives. And then it stops at 330. What about if I have an angle that's bigger than 330? How do I use it? How do I use this? Okay, so we go the opposite direction, right? So the opposite direction. So negative pi over 6, negative pi over 4, negative pi over 3. What coordinates do they have? What coordinates do they have? Okay. Okay. So how do I use my chart? That's what I'm asking. I know how to do it. That's why I'm trying to get you guys to say I know how to do it. So if you guys know how to do it, tell me so we can go on to the next thing. But I know how to do it. Tell me, how do I use my chart to use negatives? Because this is the biggest, I get this question so much. I couldn't do the negatives because my chart doesn't have negatives. I don't know how to do negatives, right? In this class, that's not an acceptable answer. In trig, it's a question we talk about. But in this class, you can't say that because you need to know how to do it. It's one of those prerequisite things. So that's why I'm going over it. So how do I do negatives on use my chart to do negatives? How do I use my chart to do negatives?
Maybe we could say that as they are in the lower quadrants and they are the same points as they are above, and they're just like opposites, so they're negative.
Where do they share the same points? That's what Arthur you were kind of getting at. Where do they share the same points? So negative pi over 6 shares a point with which of my positives? Pi, yeah, right here, right? 330, 11 pi over 6. All right? 11 pi over 6 shares a point with negative pi over 6, right? And 7 pi over 4 shares a point with negative pi over 4. And 5 pi over 3 shares a point with negative pi over 3, right? They share points. They're at the same location, right? They're at the same location, so we can just use those points. Okay, so did any of those values make this true? Did any of those values, now that you know how to use the table for negatives, check it for negatives. Are any of the negatives going to be where this is true? Right? We checked it for positives, but now negatives. So are any of the negatives, do I need to add to this list? Mm-hmm. Okay, so let's see, negative pi over 4. Negative pi over 4, we said, was the same thing as 7 pi over 4, right? So what is sine at 7 pi over 4? It's on your sheet. Okay. So what is cosine at that point? Okay. So what is cosine at that point? So are those the same? Then that's what I'm saying. Are there any negatives that we need to add to this list? That's what I'm asking. Are there any negatives that we need to add to this list? Now that we know how to use the table with negatives, because no one checked negatives before, now we can check negatives. So are there any negatives that we need to add to this list? None that fit this interval. None that fit that interval, right? There are negatives. There are negatives. There are negatives that would share sine and cosine values, but none on our interval. So the only one we're concerned about is pi over 4. That's the only one we're concerned about. We've checked positives, we've checked negatives. The only one that works is pi over 4. That's our critical value. Okay? So now what do we need to do? Now that I got a critical value, what do I need to do now? Okay, so let's draw a number line. What goes on that number line? Pi over 4. What else? Oh, so the intervals, we could put the intervals on there. Is there any other numbers I need to put on that number line though? No. Is there anything else? Is there anything else I need to add to this apart from the intervals? Not zero. Is 0 a critical value? Nope, doesn't go on there. Is there anything else I need to put on there? It's kind of a trick question.
Is it negative c squared by 2?
Where'd you get that? Where'd you get that number? So was that a critical value? Is that where sine and cosine are the same? Because if it is, if they have the same sine and cosine value, then they're a critical value. If they don't have the same sine and cosine, I don't need to write them down. So is there anything else I need to put on here? The answer is no, I don't. There's nothing else. There's nothing else. Okay? Like I said, it was a trick question, but you have to know because there's nothing else. There's nothing else we need. Okay? So now what I want you to do is finish the question. Find the relative extrema. Find the relative extrema. Go ahead. So we want to check something that's bigger than pi over 4, but not bigger than pi over 2 because that's as big as the interval. Well, pi over 4, sorry, is right here. Pi over 2 is right here. There's one thing above it, pi over 3. Yeah, so let's use that. The easiest one to use, I would say, is pi over 3. Pi over 3, pi over 3, pi over 3. Okay. So sine of pi over 3 is the square root of 3 over 2. Okay. Cosine of pi over 3 is 1/2. The squared part means I just square my answer. So whatever answer you get, you just square it. So I'm going to square each of those. So when I square the square root of 3 over 2, I get 3 over 4. But then there's a negative in front. So it's negative 3 over 4. Okay. Square 1/2, and I get 1/4. Add them together, I get negative 2 over 4, which is equal to negative 1/2. That's a negative number. So negative, 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 negatives over here. Okay, so now I got to look at values that are less than pi over 4. But, so pi over 4 is here. Pi over 4 is here. So less than pi over 4. So somewhere between those yellow highlights there, somewhere here. One of these values here I got to check. I would avoid using the negatives just because why use a negative when you don't have to? So I would stick with either pi over 6 or 0. That's the one I would stick with. And I'd probably pick 0 because always use 0 when you can. So 0, negative sine squared of 0 plus cosine squared of 0. So sine of 0 is 0. Cosine of 0 is 1. Okay. 0 squared is 0. Negative 0 is still 0. Plus 1 squared is 1. Positive number. Okay. So anything less is going to be a positive number. Okay. So now my question is, we know negative, what is pi over 4? It's a critical value, but what's also happening at pi over 4? Because that's what the question is asking. What's also happening at pi over 4? Yes, we know that because it's a critical value. So what's happening at pi over 4? And we're trying to answer the question. Mm-hmm. What does positive mean? Those pluses, what does plus mean? Plus, plus, plus. Well, what do those pluses mean? Tell me what those pluses mean. Mm-hmm. Increasing, that means going uphill. And then what do those negatives mean? Decreasing. So if something increases and then after decreases, that's the definition of a maximum. Okay. So we're going to say relative maximum at x equals pi over 4. Okay. That question was actually a question I took off. This question number 6, I put it on here on purpose because it was a question I used to have on FRQ for this chapter, the FRQ for this chapter. Because you can write it down right now. When we eventually take this test in a few weeks, you're going to have FRQs that talk about relative maximum, relative minimum, increasing, decreasing. That's where the FRQs are going to be. Because FRQs love questions about where is it increasing, where is it decreasing, where is it concave up, where is it concave down, what is the maximum, what are relative extrema. Okay, so this is one I took off of there. I don't put on the test anymore because I thought it was a good question to put on the notes. Okay, so that's a question that FRQ for sure you're going to be asked to do. Find relative extrema, increasing, decreasing, kind of like what you're going to be asked to do on Friday on the quiz. Those types of questions. Okay, so the quiz is going to be free response. There won't be any multiple choice on that because of that. Okay. All right. So now what I want you to do is do the last one, number 7. Number 7 brings in everything. They want you to find critical values. Where is it increasing? Where is it decreasing? Where is it concave up? Where is it concave down? Where are relative extrema? Where are the inflection points? Are there any vertical asymptotes? So it's kind of like everything. Okay. So this one's going to take a little bit of time. So I'm going to give you some time to do it. I want you to do each of those. Okay, so I didn't finish it, but I did most of it. So critical values, I need the first derivative. Increasing, decreasing, I need the first derivative. Concave up, concave down, I need the second derivative. Relative extrema, I need the first derivative. Inflection points, I need the second derivative. Vertical asymptotes, I don't need any of that, right? First thing I did was vertical asymptotes are where can the function not exist? What value of x could I plug in that would make the function undefined? 4. If I plug in 4 for x, it's going to make the function undefined. I could plug in 4 here, but if I plug in 4 here, that's 0. So 0 means doesn't work. If you don't believe me, plug in 4, use your calculator. Plug in 4 here, plug in 4 here. Calculator will say can't do it. Okay, so there's a vertical asymptote at x equals 4. You don't need the derivative to tell that. Okay, now to do most of these, you need the first derivative. So that's what I found. I found the first derivative. Okay, so this guy, you find the derivative of this guy, which is easy, 1. And then you find the derivative of this guy. This guy is a rational expression. It's a fraction. So you use the quotient rule. Okay. So I use the quotient rule, and I got this. That's my derivative. Problem was the next steps, I needed to find increasing, decreasing. Okay. That means I need to set it equal to 0. That means I need to have a numerator and denominator. So what I did was, here, I just did common denominator. Common denominator is x minus 4 squared, so I gave common denominator, so I combined them to make 1. So those both yellow boxes are the same. They're the same answer. So to find critical values, I need to set the top equal to 0. I need to set the bottom equal to 0, which is what I did next. When I set the top equal to 0, I got 2 answers, 6 and 2. When I set the bottom equal to 0, I only got one answer, 4. Okay. Did the first derivative test, plugged in values that were bigger than 2, in between 2 and 4, in between 4 and 6, in between after 6. So I plugged in 0, I plugged in 3, I plugged in 5, I plugged in 7, and I got that. Okay. Now, what I need next is second derivative. Okay. Second derivative is right there. Second derivative is right here. That's the second derivative. And I can actually factor it even more because they both have x minus 4s. So I can factor this guy with actually this guy. So the second derivative is actually 8 over x minus 4.
Where did the x minus 4 squared come from?
Oh, sorry, supposed to be to the fourth, right?
Yes.
So this is to the fourth, so this would be to the third. There you go. Thank you. Okay. So now I need to do the same thing I did for the first derivative with that guy. Okay. So I'm going to set the top equal to 0. Well, the top can never be 0. It's just 8. But the bottom could be 0. So let's see. So x minus 4 cubed equals 0. Okay, so take the third root of both sides. X minus 4 equals 0. Add 4 to both sides. Okay. So I have a critical, actually I have an inflection point at 4. 4 is an inflection point. Okay. Now the last thing is concave up, concave down. So the second derivative is right here. The second derivative is right there. So what I'm going to do now is I'm going to plug in numbers bigger than 4, smaller than 4 into that guy and see what happens. So 0. I get 8 over, what is that, negative? It's going to be a negative number because you're going to get negative 4 inside the parentheses. And then you're going to get cube it. So if you cube a negative, it stays negative. So what is that? I think it's 64. So negative. Okay, so now I'm going to plug in a number bigger than 4. One cubed is 1, so that's positive 8. Okay. So the work is done. Now I just have to sum it all up. Where is it increasing? Where is it decreasing? Where is a critical value? Where is a maximum? Where is a minimum? Where is concave up? Where is concave down? Where are the inflection points? So I have to sum those all up. Okay. So I'll write it down right here. So let's start with the first thing. The first thing was critical values. Critical values. Okay. Critical values at 6, 2, 4, and 6. X equals 2, 4, and 6. Okay. The next thing was increasing, decreasing, increasing, 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 negative infinity to 2, 6 to positive infinity. Okay. Decreasing. In between, 2 to 6. Probably at 4, it tapered off. So probably what happened at 4 was it was decreasing, and then it kind of did one of these things and then kind of slowed down. So actually, probably it would be probably 2 to 4, 4 to 6. You wouldn't include 4 in there because at 4, we know there was a 0. Derivative was 0. So we would say 2 to 4, 4 to 6. Okay. Inflection points. Points of inflection at x equals 4. Yep. Concave up, concave down, concave up. Bigger than 4. Concave down. Less than 4. And I think that's everything. Trying to go a little fast here because we're running low on time. Extrema, sorry, relative extrema. I didn't do relative extrema. Where am I going to have maximum minimum? At 2 and 6, yeah, 2 and 6. 2 and 6 maximum minimum. And 4 is not a maximum or minimum. So at 2, what am I going to have? Maximum. At 4, I'm going to have a minimum. Okay. You guys got it? Okay. All right, so last thing. Tomorrow, I'm going to give you time to do the assignment in class because I know some of you guys are going to be out for SAT. So that's all we're going to do is the assignment in class. Friday, we have a quiz. First thing we're going to do is the quiz. It's only 3 questions, so it won't take you that long. What is the quiz going to be on? First derivative, first derivative test, second derivative test, and mean value theorem. Okay, those are the 3 things. All right, which we're going to go over tomorrow. All right, guys.